talking about today is, it's two topics, but they really go together, exponentials and logarithms. Have you ever heard either one of those words before?
Yes.
On the ACT? Logarithms are on the ACT.
Oh, yeah, there's one thing that's wrong.
Well, you're not going to get it wrong next time, see?
Whoa.
Ladies and gentlemen, the discovery of logarithms in the 1600s allowed the scientific revolution to begin. Why? Because logarithms are a way to take really, really, really big numbers and make them into a small number that can be managed. Logarithms are used to determine the strength of an earthquake. Do you know what's the scale called? The Richter scale, right. The Richter scale is on what's called a logarithmic scale. The Richter scale uses logarithms. And we're going to talk about earthquakes later. Do you know what sports arena has had the loudest sound recorded? Not Denver. Kansas City. Arrowhead Stadium in Kansas City has had the loudest sound recorded. Sound is measured in decibels. Sound is measured on a logarithmic scale. All right. So why do you have something that has inverses? Because you have to remember how to do your inverses before you can start thinking about exponentials and logarithms. What I want you to do is take that orange paper that I just gave you, and I want it to be at the very top of your next page, which is page 90. Oh, the title, duh. On your table of contents, your page 90 is going to say inverse review. Your page 91 will say logarithms. Now let me show you what that page 90 is going to look like in your notebook. I know you can't see my writing, but I know you can see orange and green. Your orange is up here at the top. You're going to do a little bit of work here, and then you're going to have a green one to go about halfway with a few problems right here, okay? Then you're going to have a booklet that will go on the next page. Yes. Stop. Yes, you
were cool. Last one killed the vibe. You said it. I just said for today. For today. Tomorrow, I'll give you.
All right. Okay, so this orange sheet says finding inverses. Now, let's do some review. We're not even going to look at this yet. Don't write this down. I just want your brain. I give you f of x equals 3x minus 2. What's another name for f of x? Y. So this says y equals 3x minus 2. Now remember, there's a college algebra way to do inverses, and then there's the short way, which is just thinking through it. Well, that's the college algebra way, switching x and y. We're not going to do that yet. Give me just a minute. Let's look at that x. What happened to that x first? That x is walking down the street, and what happens to him? It gets multiplied by 3. So now 3x is walking down the street. What happens to it? Subtracts 2. To find an inverse, you go backwards and undo. So you're going to add 2 and then divide the whole mess by 3. And that's your inverse. Do you remember that? Now, let's do the college algebra way to get the same answer. And you're going to say, why do I have to do the college algebra way? Because sometimes this way won't work. All right. I want you to look at the 4 steps right here. These are the college algebra ways. Step 1, replace f of x with y. Done. What's step 2? Switch x and y. What's step 3? Solve for y. How do we get that y by itself? Say again. Add 2 to both sides, so that'll be x plus 2 equals 3y. Divide both sides by 3. You get y equals x plus 2 divided by 3. Oh my gosh, that looks familiar. And then what's the last step? Replace y with f inverse of x. You learned it, yeah. Okay, so below where you glued this in, you're going to have 3 problems. And I want you to do them 1, 2, 3. Do them across that way. Okay. Let's do the one we just did. F of x equals 3x minus 2. Now let's find the inverse using the college algebra way. So let's just do what we just did, okay? Look up at your orange if you can't remember the steps. First step, replace f of x with y. Second step, solve for x. No. Well, yeah, switch x and y first. Switch x and y first. Right, because what are we doing now? Solve for y. Good. So we're going to add 2 to both sides. And then divide by 3. Last step.
Y with F.
Replace y with f inverse of x. I understand. You need a day of 2 plus 2? Yeah, you just get bored.
Well, I feel smart. That's what I want to be ready.
You are smart, so.
Yeah, but like I don't feel it at the moment.
But you don't feel it at the
Because
moment.
my brain's.
I hear you. I hear you. Number 2, h of x equals x squared plus 6. All right, let's think through it the fast way. And you may say, doing it the college algebra way is fast. It is once you remember the steps. What happens to x? Don't write this part down. What happens to x as he's walking down the street? He gets squared, and then add 6. Undo.
Oh, negative 9 minus.
Subtract 6. And then, how do I undo squaring? That better be our inverse, right? That better be our inverse.
That's what I was thinking.
Okay. So let's do it the college algebra way. Ready? First step. What do I do with this? Change it to y. Then switch x and y is step 2. What's step 3? Because what am I doing? Solve for y. So I get x minus 6 equals y squared. How do I get y by itself? Square root. Now, one thing I want you to know here. Don't put plus or minus. Don't put plus or minus. The reason for that is if you put plus or minus, then what you end up with is a parabola over on its side that's not a function because it'll fail the vertical line test. So don't put plus or minus, just put the plus. Okay, one more. I'm just going to start this with y equals. Oops, I'm going to have to write smaller. Y equals 4 to the x power. Step one's already done. What's step two? Switch X and Y. What's step three? Solve for Y. What do you do? You don't have a clue. Well, I can't divide by 4. That's a good thought. I can't divide by 4. Where is the Y? It's in the exponent. Guess what? When you have a variable in the exponent, what you have is called an exponential. A variable in the exponent is called an exponential. Now, so the question is, how do you undo an exponential? A logarithm. A logarithm. Oh my, what do you mean no? You're hurting my feelings here, Gavin. There's something I'm looking for here. Hurting my feelings. The reason I gave you M&Ms was you're going to watch a short video. We're going to watch it up here. There's a different video, a short one that you're going to watch on your own Chromebook about exponentials that involves M&Ms. So I thought, since it's the first day back, I'll just give you some M&Ms. So, now, so give me just a second. Let me get this video up. And yes, you may eat your M&Ms. Please, 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 when you leave this classroom, put the trash in the trash can. If I see stuff in the floor, I'm going to be mad. So in that video, snap. You had 2 to the first power, you had 2 to the second power, you had 2 to the, come on, Stan. You had 2 to the third power. What did the exponent mean? How many 2's? Right. So what's another thing that it meant? What? How many days? Yeah. How many would you get on the first day? 2. How many would you get on the second day? 4. On the third day? 8. On the fourth day? Notice that what is changing is the exponent. The base, which is the big number, stayed the same. Where did that big number, the base, come from? How many you got the first day? Right. How many you got to start? So, ladies and gentlemen, this is an exponential. And a logarithm will undo an exponential. Okay? Now, let me see here. Okay. So now you are going to get a green paper. Now, on that piece where you have x equal 4 to the y, leave it. Don't write anything there. You don't know how to finish it at this point. I'm going to give you a green paper. You need to glue or tape it right under the work you just did. On your green, the title says Inverse Exponential Function. So let's read. The inverse of an exponential function is called a
Logarithm.
logarithm. You're going to write the word logarithm in that first blank. And is written as, you don't have any idea what a logarithm looks like when you write one down. Here's what it looks like, and you're going to write this in the next blank. Now, I want you to notice that little b is a subscript. Make it low. That x is just on the same line as log, so don't make the x go up high. I'm going to tell you the way you read that. You read that as y equals log base b of x. Y equals log base b of x. Now, what in heaven's name does that mean? In your last line, it says where blank is the base. What did I say? Log base b of x. B is the base. In the M&M's problems, what was the base? 2. So if we were doing M&M problems, this would be a 2. Okay? Yep. Okay. Then you've got 3 boxes. It says exponential function, and I want you to write this. Y equals b to the x. Y equals b to the x. Question? You see the 3 boxes that are at the bottom of that green? The first box. Don't write this down. What would that mean in that M&M video? On the 3rd day, I would eat 8 M&Ms. All right. So let me show you this. Don't write this down yet. I just want you to look at this. If we take that exponential and rewrite it as a logarithm, it's going to look like this. What's the base? Now, what's the base? 2 is the base. Log base 2 of 8 equals 3. Don't write that down. The other video that you're going to look at in just a little bit is going to talk you through this. But I want you to notice, this is the big deal. Where's the exponent? Here. Yeah, it's the answer. What you have got to remember out of all this, the answer to a logarithm is an exponent. The answer to a logarithm is an exponent. I will say that 50 times. Now, let's go to your second box. Notice your second box says switch x and y. So if we switch x and y out of this, what's it going to look like? Now, how would we write that as a logarithm? Can you think about that based on what I just did? And I know you only saw it once. Log base b. Now, the answer to a logarithm is an exponent. What is the exponent right here? Y. So that has to be the answer. So what has to go right here? This goes in your last box. These are inverses of each other. Now notice where things go. Your base is your base, okay? The exponent, oh, hang on, sorry. When you switch the x and the y, that exponent is your answer, okay? So let's go down here right under, and I want you to write this. Find the inverse. Find the inverse. Right under the green. We're going to do 4 problems. We're going to do 1, 2, and then we're going to do 3, 4, like that. All right. We're going to find the inverse. What are the steps in finding an inverse? Replace f of x with y. Done. Switch x and y. Do that. And remember, before, that's where we got burned because we didn't know what to do. We're going to rewrite that as a logarithm. Log base, what's the base? 4. That's the inverse. And so when you take the ACT next time, you won't miss this. What's the last step? What's the last step?
Uh,
Replace. Look in your orange sheet. Replace y with f inverse of x. That's the inverse. That's the inverse. Replace x, or excuse me, swap x and y, and then rewrite that as a logarithm. Let's try a second one. Y equals log. Oh, I'm giving you, on this one, we're going the other way. We're going the other way. All right. What's the first step? We swap, we substitute y in for f of x, and then switch x and y. So switch the x and y. Now, rewrite that as a logarithm. Do you remember what I said that I was going to say 50 times? The answer to a log is an exponent. What is the answer to this log? X. That's going to be the exponent. What's your base? What's your base? So 6 to the x equals 1. That's your inverse. Got to do this. I'm going to do 2 more. Logarithms are not hard if you just remember that the answer to a logarithm is an exponent. Number 3. Y equals 1/2 to the x power. What are the steps to finding an inverse? Look at your orange sheet if you forget. Switch x and y. So we have x equals 1/2 to the y power. Now solve for y means rewrite it as a logarithm, because guess what? The answer to a logarithm is an exponent. And what's the exponent?
X.
Y. Oh my gosh, that's how I'm going to solve for y, because the answer to a logarithm is an exponent, and y is the danged exponent. Okay, so what are you going to write? Log, what's the base? And put it down there. Log base 1/2 of x equals y. But I'm not finished. Yep. All right, we got one more. Number 4. Y, where did my number 4 go? I thought it did, and I don't know. Y equals log base 2/3 of x. What are your steps? Switch x and y. Now we're going to rewrite that as an exponential. Okay? Rewrite that as an exponential. The answer to a logarithm is an exponent. So what's the exponent? Yeah, so 2/3 to the x equals y. If you've got a fraction, put the fraction in parentheses, because if you don't and you write this, how do you know what's raised to the x power, the 2 or the 3 or both? You don't, so put it in parentheses. And then f inverse of x equals 2/3 to the x. Is this making sense? Yeah, we're not going to have enough time. I'm going to give you the booklet that goes on the next page. We'll do the booklet together. Let's get started with the booklet. I want you to have a little time in class to at least get started on your homework. Now, you'll notice I heard somebody say, oh my gosh, there's all these problems. These problems are very, very short. All right? Very, very short. Yeah, you will not have anything else on that page except this booklet. I hope, I'm assuming you're going to need your calculator a little bit, and maybe you can do it all in your head, and if you can, that's great. Review, don't write this down. What's that? No, I'm not, no. No. Remember when you have a negative exponent? He's not happy where he is, so he's got to go downstairs? Yeah, oh, quit. What's 2 to the negative 3 power? 1 over 2 to the 3rd, which is 1/8. Don't forget your negative exponent rules. You will need them. All right, on the front of that booklet, in the box, you're going to write 2 lines. Top line, you're going to write this. No, here's what I'm talking about. In the box. In the box, you're going to write 2 lines in the box. 2 lines in the box like this. Okay? 2 lines in the box like so. Everybody understand? 2 lines in the box like that. 2 lines in the box like this. Now, the line underneath this is just, how do you read this? Put it in quotes so you remember, oh, that's how you read it. Log base B of A is X. That's how you read it. Log base B of A is X. Under that, where it says the question. The question. Here is the question, and you're going to write the question. What exponent is required to go from a base of B to a value of A? Do you remember when we wrote log base B of A equals X? In a logarithm, the answer to a logarithm is an exponent. What's the base? B. So the question is B to what power equals A? That's what this says right up here. What power do I have to use so that B to that power is equal to A? All right? At the top of that paper, right above the word logarithm in the log, Miss Ulaga was humorous putting a log there. I want you to write this, and I don't want you to ever forget it. The answer to a log is an exponent. Are you writing that at the top of your paper? Because that might be on a notebook quiz. The answer to a log is an exponent. You can look here at the bottom and see the setup. Let's go inside. Everybody ready to go inside your booklet? I could ask how many exclamation marks did I put? No, I won't do that. All right. I'm just being stupid. First part, you notice it says evaluating logs. This is ACT stuff, all right? Number 1, Number 1 says, and you may need your calculator for this, I don't know. When this is the question, the answer to a log is an exponent. So the question is, what exponent do you raise 4 to get 64? On your calculator, if you need to, do 4 times 4 equals, and then times 4 equals, and times 4 until you get 64. It's 3. Because 4 to the third power is 64.
Wait, hold on. Because 2 to the third times 2 to the third equals 64.
No, because 4 to the third power, which is 4 times 4 times 4, 16 times 4 is 64.
What I was saying was like 2 to the third power times 2 to the third power equals 64. And 2 times 2.
That's true, but that's a different base.
Yeah.
But yes, what you said is true. Well, you are smart. So, number 2, log log base 6 of 216. What are you thinking? 6 to what power is 216? 3. Because 6 times 6 times 6 is 216. What do you think number 3 is? 4. Number 3 is 4 because 3 to the 4th power is 81. What about number 5? 4. What about number 4? Number 4 is 3. Number 5 is 5. Good. Number 6. Number 6 is 2 because 8 times 8 is 64. What about number 7? Number 7 is 2. Number 8. Yeah.
4.
How'd you get it? You did 9 times 9 equals, and then times 9 equals, and then times 9 equals, and figured out how many 9s that was. That's 4. What about number 6? Number 6. Did I say number 6? Number 9 is 5. Questions there? You're struggling? Give me a thumb. I got it. Kind of got it. I ain't got it at all. Okay, I see a few kind of going like this. All right. Go to the star. The first star, the top one. Smart aleck. I want you to, let's look at the problem, and then we'll talk about what the star says. The answer to a logarithm is an, so this question says 343 to what power is 7? Let's talk. Could it be negative? If it's negative, then you're going to end up with a fraction. Why? What did you put in your calculator? How did you know to use that? That'll work. Guess and check will work. Guess and check will work. Ladies and gentlemen, listen to me. If, that's right. Hey, if your base is bigger than your exponent, excuse me, is big, fiddle. If your base is bigger than this number, your answer is going to be a fraction. So please look at the first starred item. When the base number is smaller than the answer, the exponent needs to be a fraction. Remember, now this is what Levi said. Levi did 343 to the 1/3 power. You guys remember this from last semester, but you may have kind of forgotten it a little bit. 343 to the 1/3, Gavin said, is the same thing as the cube root of 343.
Oh.
And the cube root of 343 is 7. But we have to write this as an exponent, so we'll use 1/3. So the answer to this one is 1/3. Well done, Levi. Look at number 11. log base 32 of 2. Will your fraction, fiddle, golly bum, will your answer be a fraction?
Yes.
It will. Now, let me show you something. My favorite uncle, who was a 6th grade teacher in Fort Smith for 30 years, his cuss word was fiddle. And so I say fiddle.
No, that wasn't fiddle. It was golly bum.
Oh, well, all right. Well, I say that too.
That's my favorite.
That's a
thing
new
I've
one?
ever heard in my
Oh,
entire
well, all right.
life. You say that was
32 to what power is 2? Well, let me show you something. You're right. You're right. Let me show you something. What if we turned it around? 2 to what power is 32? That's 5, right? So going the other way is going to have to be 1/5. Ah, so, yeah, it does. Yep.
Wait, 3 to
So,
8, so
the question, go back to this one. The question here
1/4.
was this, right? But if we had done this, just turned it around,
Would it help?
we'd have gotten 3.
1/3.
So this is going to be 1/3. Good. Good.
Terrified.
I'm glad. I'm glad. Number 12. Log base 81 of 3.
Oh. It's uno. C. No. 5. 3.
What's the answer to this one?
4.
4. So what's the answer to this one? 1/4. 1/4. Okay? Go to the second star. Second star. Shh. When the numbers switch between a fraction and a whole number, the exponent will need to be negative. Negative is what you're going to put in that blank. Do you see that the base and the big number change between a fraction and a whole number? All right, so our answer is going to have to be negative. But look, let's do this like kind of like we did the last one. You ready? I'm cramming a lot of stuff down your throat, but I hope you're understanding. 3 to what power is 1/243? Well, snap, I don't know. But what about this? What about this? 3 to what power is 243? Do this. Do this. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. This is 5. To throw that down into the denominator of a fraction, that's going to be -5. Log base 1. What the devil is that? Log base 1/2 of 2. All right. The question is 1/2 to what power is 2, right? That's the question. Let's do this. Let's flip the one that's a fraction. 2 to what power is 2? 1. So what's this? -1. Shut the front door. 1/2 to the -1. Doesn't that say, hey, nobody's happy. He's got to go downstairs. He's got to go upstairs.
Oh.
Okay, next one. Log base 2 of 1/128. You're thinking this. Let's think this. 7? So what's that? -7. That's all there is to logarithms. That's it. That's all there is to logarithms. All right. I'm not going to discuss the start item yet. Let's look at number 16. Log base 2 of 1. What's the question? 2 to what power is 1? 2 to the first power is 2. What? 0. Remember, any number to the 0 power, any number to the 0 power is 1.
They're all going to be 0.
They're all going to be 0?
The last one will be.
The last one will be. Look at the last one. Look at the last one. Log base 1/2 of 1 is asking you 1/2 to what power is 1? 0. Now, look at the middle one. That middle one says ln. That comes from, are you ready for this? Logarithmus naturalis. That is Latin. That is Latin. All right. That is Latin, and so we interpret that as natural log. Natural log. So ln. Now you're like, well, where's my base? On your calculator, you have a button that says E. Now, it is second division symbol. Do second divide. Second divide. And hit enter. Hit enter. That number goes on and on forever. Guess what? Just like pi. Just like pi. On and on forever. Ladies and gentlemen, that number right there is named for this dude. You know how to pronounce it? His first name is Leonard, but it's pronounced Euler. Leonard Euler. Don't ask me why, but he's not, he's European German maybe. Leonard Euler. No, maybe he's Swiss. Anyway, Leonard Euler discovered this number. And this number appears in nature. We will not go into that. But when you see ln, it means the same thing as log base E. So below on number 17, you see on number 17 where it says ln of 1? I want you to write below that, log base E of 1. This ln, that's the only log we use in calculus. The only one. We don't use any other log in calculus. So if you want to, you can think about it like this, as log base E. So what's that equal? Well, E to what power is 1? 0. Because anything to the 0 power is 1. You were right. You were right. Look at your last star. No matter what the base is, if the answer is 1, the exponent needed will be 0. If no base is given, it is assumed to be 10. Put a 10 there. Now, here's what we got to talk about. Go to the next side. Do you see this example right under that box? See right under that box? If you see log and you don't see a base, that's base 10. You see at the top where it says, oh no, my logarithm has no base. I want you to write this in the box. If no base is given, the base is 10. Doing okay? You got this? We got to. We got to. Miss Logger talks faster than I do, and she'll be finished, and she'll say, why didn't you finish? Okay. So what is the log of 10? What's the base? 10 to what power is 10? 1. 1. Next one. Log of 1 over 100. What's your base? What's your base? 10. 10 to what power? You're going, now listen, you got a big number and you got a fraction. Switch them. 10 to what power is 100? 2. So 10 to what power is 1 over 100? Negative 2. Negative 2. What about the last one under there? Log of 1,000. What's your base? 10. 10 to what power is 1,000? 3. 3. Go over to the right. You see it says log, Bella, bless you. You see that? What you're looking at right there is how do you rewrite that as an exponential? Put yourself a little arrow. Oh, sorry, it's already there. Not the arrow, but what's your base? B. What's the exponent? Because the answer to a logarithm is then, so x is the exponent, equals the other number. We should be able to sail through these pretty fast. Right below that it says log base 4 of 64 equals x. Go right under that. How do we rewrite that like this as an exponential? 4 to the x equals 64. Good. 343 to the x equals 7. How do we rewrite that as a logarithm? What's the base? 343 is the base. Because the answer to a log is the exponent. Okay. We got 12 questions. That ought to take us about 30 seconds a question. Look at number 1. Log base 6 of 36 equals 2. Rewrite that as an exponential. That's right. 6 squared equals 36. 9 to the negative 2 equals 1 over 81. How do we write that as a log? The base is 9. The answer to the log is the exponent. (64) to the 1/2 equals 8. Log base 64 of 8 equals 1/2. There you go. There you go. You're doing fine. 9 to the x equals y. Log base 9 of y equals x. Good, good. Number 5, log base x of y equals 4. Write it as an exponential. There you go. There you go. Number 6, is that where we are? B to the a power equals 123. Base b of 123 equals a. Number 7, 6 to the m equals n. Log base 6 of n equals m. Log base u of 15 over 16 equals x. U to the x equals 15 over 16. Gavin, you all right?
Yeah.
Good. We're all going to be tired, me too. Okay, where are we? Number 9, 8 to the b. Okay, say log base 8. Log base 8 of a equals b. Log base 8 of a equals b. Number 10. Now, number 10, yeah. Do I not even need to write it down? What's the answer? 2 to the y equals x. How would you rewrite number 11? 14 to the negative 2 equals 1 over 196. There you go. There you go. And we've got one more. I'm going to write this one down. Log base y of x equals negative 8. Guys, you did great. You did great.